Hi, my name is Aaron Chang. I'm an urban designer and educator. I'm also co-lead of the Water Leaders Institute. Excited to share a little bit about how water flows through the city today and how it relates to buildings and building sites. We're going to do this by stopping at a couple of different locations around the city. The first spot is right here next to drainage pump station number 1. The Sewerage and Water Board operates 24 of these pump stations around the city, and they're absolutely critical to how water flows. This location is in what's known as the Bowl of New Orleans. Unlike in most places, the high ground is by the water. Over dozens of years, the river would overflow its banks every spring, and in doing so, it would also deposit fresh sediments. The heaviest sediments would fall out closer to the river, and then the lighter silts and clays would fall out farther away from the river. Here we are a couple of miles from the river. And so in that way, the land built up so that you had the high ground next to the river, and then it would slope down into the back swamp. So this area, before humans inhabited it, would have been back swamp and marsh. And so in the early 20th century, the Sewerage and Water Board started to build these pump stations at locations like this. This was the city's first pumping station. Inside of these pump stations are massive, what are called wood screw pumps. And so when water flows, when it rains on the high ground, when it rains on the city, and we get over 60 inches of rain each year because of our subtropical climate, so we get rain continuously throughout the year in heavy bursts, especially in the summertime. So when rain falls on the city, it flows downhill from the high ground down to low spots like this. And that's why the pump station is located in this spot. And so it catches water flowing by gravity down through the city's drainage pipes. So water first enters into almost every block of the city. So the water flows through these pipes into bigger and bigger pipes and then culverts, which are large underground concrete boxes essentially. So we're actually standing on top of one right now here on MLK Boulevard. So water flows through these culverts down towards our pump stations by gravity, and when it reaches one of these pump stations, there's actually, you can't see it, but underneath that concrete apron, there's a massive tank. It's called the suction basin. So those pumps, they have a simple job. They function kind of like a straw. Inside of the suction basin, the pump removes that water. It creates a vacuum up high, and that enables the pump to pull the water out of the suction basin and lift it and discharge it on the other side of the pump station at a higher level, so that it can then flow by gravity to the next pump station, where it's then lifted again, and from there it then flows out to Lake Pontchartrain and out of the city. Here we are on the discharge side of drainage pump station number 1. You can see those tubes coming out of the station, and so those tubes are the outfalls for the wood screw pumps that are inside of the station. So now the water is a couple of feet above sea level again. So on the other side, the water was below sea level as it's flowing into the pump station, and the pump station lifts it up and discharges it on this side above sea level so it can flow by gravity out towards pump station number 6, and there at pump station number 6 it's lifted up again to be above sea level, and from there it can flow out to Lake Pontchartrain, which is at sea level. You can see a couple of things here. One is that this water has bits and pieces of trash in it, and this is something that's absolutely critical to keep in mind. Unlike older cities where you might have combined sewer systems, in New Orleans, the drainage system and the sanitary sewers are completely separate. And so what that means is that none of this water gets treated before it goes into Lake Pontchartrain. Anything and everything on our lawns and in our streets makes its way into the pump stations and gets pulled through and discharged out into canals like this. This is called the Palmetto Canal, and from there into Lake Pontchartrain. So it not only has a lot of costs in terms of what it takes to remove, to like constantly be fishing trash out, but also it has a negative impact on the water quality of Lake Pontchartrain. The other thing I want to point out is that the fact that there's water flowing right now. And so again, we're in a neighborhood that is below sea level. And so if you think about it, we have the Mississippi River, which is high, and that's flowing out to the ocean, to the Gulf of Mexico. And on the other side, we have Lake Pontchartrain, and that's at sea level. So we have high water that's higher than the city on both sides. and that water is constantly kind of pushing. It's trying to find equilibrium. And so again, if you remember, this area used to be a swamp, which means the water table would have been coterminous with the ground that we're standing on. So it starts to make sense. This bowl is trying to fill back up with water. The water wants to equalize. And so even on a dry day, it hasn't rained here in New Orleans for a couple days now. Even on a dry day, there's constantly water entering into the suction basin of the pump station, entering into our pipes and into our underground drainage culverts, because that water is trying to level out and fill the bowl. And so that means even on a day like this, the Sewage and Water Board is operating pumps to keep draining the swamp, essentially, to keep water moving, and so that this bowl doesn't fill up with water. When it rains, the discharge basin fills up incredibly fast with water. So when you have each of those pumps running, this thing, if you look around us, look at how massive this cross section is, this whole thing will fill up pretty much to the brim. And that's water from all of Uptown and Central City, Lower Garden District, all that is flowing downhill to Pump Station 1, and all that then has to get flushed out to the lake. And so what you can see is the concrete. This is unlike a natural riparian corridor, this isn't filled with vegetation, there's nothing absorbing the water. It's basically a concrete channel that's slicked up to move that water as quickly as possible. And so the paradigm for the last century has been to move water that falls on the city, to move it out of the city as quickly as possible, which is why you see the underground drainage culverts, you see the massive pump stations, and you see channels like this, the Palmetto Canal. Again, this is sort of like a massive conduit to move water quickly from point A to point B. So in this case, Pump Station 1 to Pump Station 6, and from there out to Lake Pontchartrain. And so with this system, we actually spend over $50 million each year removing stormwater out of the city so that the bowl of the city doesn't fill up. And an important thing to keep in mind is 24/7 you have pump station operators, highly trained, manning these stations on guard in case it ever starts to rain and the city needs to start running these pump stations to keep neighborhoods dry. So here we are in Broadmoor. We're just a couple blocks away from drainage pump station number 1, and we're still in the bowl of the city. So again, the river is behind the camera, and the ground slopes from the river down to this area, which is below sea level. And so we're in what's called the bottom of the bowl. And again, that's why the pump station is there, to remove water from the bottom of the bowl and to allow it to drain out to Lake Pontchartrain. Some of the impacts of the pumping are pretty significant, though, when we think about development, when we think about where people live, and what it means to build in New Orleans. So Broadmoor is one of New Orleans' beautiful historic neighborhoods, and you can see even just on these few blocks alone, all of these raised bungalows and raised homes, and that's a traditional vernacular way of building that's really important because of the flood risk associated with former swampland like this. And so what's important to keep in mind is that any structure that's built in New Orleans is typically built on piles, which means that before any construction starts, a crew goes out and pounds essentially wooden piles or wooden logs into the ground, and it creates a stable platform. So there are dozens of wooden piles under structures like homes, office buildings, and then even here, earlier on we talked about the drainage culverts that bring water to the pump station. So underneath Napoleon, all of Uptown again is draining through these massive drainage culverts towards pump station number 1. Imagine underneath our feet there are actually twin box culverts. So again, massive concrete boxes, 15, 20 feet wide, 10 feet deep. And those are built like buildings. So they have wooden piles underneath them as well. And so they're supported. They're relatively stable in this former swampland, this mucky soil that we have throughout the city. Because that is stable, because the culvert is relatively stable, the ground around it is not as stable. There aren't piles supporting this part of the street. So what you can see is direct evidence of subsidence, which is the sinking of the ground. So here you have drainage culverts. They're pile supported, so they stay relatively stable while the ground around it sinks. And so you see this crack in the asphalt. And so this is a process that's happened since this asphalt was laid. And so you can see that rate of subsidence is actually not that slow. So in the lifespan of somebody purchasing a house in a neighborhood like Broadmoor or New Orleans East or Kenner, within the lifespan of your mortgage, you might see the land sink underneath your home 4 or 5 feet. That's happened over the last century. So it's a really significant thing, and that's why we actually have this bowl. That's why nearly half of the city is below sea level, is because we've been continuously moving water out of the city. Every time it rains, the paradigm has been to pump water out of the city, and that's directly causing the ground to sink, because these former swamp soils, as you pull the water out of them, they start to compress. And not only that, all the leaf litter, all the organic material that was an important part of that swamp soil, once you remove the water and it's exposed to oxygen, the organic matter starts to oxidize, and actually it's a process of decomposition, and it disappears. And so you have a further loss of volume. That's a really significant thing, because the more the ground sinks, the harder it is, the deeper your bowl gets, and the harder it is to move water out of the city. So over time, we're spending more and more and more money and energy, fossil fuels, on pumping that water out. So here we are at the front of the Keller Library. We've just rotated 90 degrees. We're still in Broadmoor. And what you see behind us is one of the flagship projects of the Broadmoor Improvement Association. So after Hurricane Katrina passed through, and after the levee failures and the flooding of neighborhoods in the city like Broadmoor, there's been an effort to rethink what it means to inhabit this former swampland that's below sea level. And so what you see is really, I think of it as an experiment that's in progress. So this is one of the most prominent and first examples of green infrastructure in the city. And this is really different from other building sites that you see. And so you can see off of the roof of this library, all the water that comes off through these pipes on the side of the building, instead of feeding directly into the city's storm drains and drainage system, from which it would be flushed out to pump station number 1, which is just down the street. What happens instead is that water that comes down off of the roof actually flows into this large rain garden. So instead, imagine if a typical building, this would just be an open grassy lawn maybe. Maybe there's some ornamental flower beds to make things look pretty. Instead, the entire site is thought of as part of the city's drainage infrastructure. You can see how this area is dug low, and so that space, it becomes a bowl in and of itself, so that water, instead of having to go into the storm drain, actually fills up this bowl. And you can see these signs that talk about prairie establishments. The city is in the process of building more and more rain gardens and really shifting how we think about the relationship of buildings and rooftops to the sites and to the city's larger drainage system. The idea, of course, is that if you can catch the drops of water that fall in this one spot and hold it in place and let it soak into the ground, it does a couple of things. One is the possibility that that water nourishes a local ecosystem. Two, that water soaking into the ground helps to stabilize the water table a bit and reduce the rate at which areas like this are sinking. And three, reducing the amount of water entering into our storm drains means that there's less water flowing through the pump stations, and that means we can spend less money on pumping. It also means that we can help reduce flooding, because when the pump stations are operating at capacity, that means all the pumps are running, but there's so much water flowing to it from all the surrounding neighborhoods that the station backs up. And water doesn't drain anymore. That's when you get street flooding. So by holding water in one spot, it means there's more room in each of our pipes and each of our culverts and at the pump station for water from other parts of the city. And so this is absolutely critical. Instead of rushing water to a pump station, it's the reverse. It's a totally new paradigm of slowing down the flow of water, catching it and holding it where it falls, so there's less water ending up at the pump station. And the last thing I want to point out is that these rain gardens, it's not just a tub with no plants. So unlike the drainage canal, which was just concrete, that was all about speed, this is all about slowing down and holding that water, because what that does is it gives time for all these plants to play an active role in cleaning the water. And so that means the pollutants, the chemicals, everything that's in the runoff coming off of our streets, coming off of our rooftops, that's actually absorbed and filtered by the soil, by the mulch, and picked up by the plants through their roots and their stems and metabolized by those plants. So it's actively cleaning the water when you put runoff into installations like this rain garden. And so the more of these rain gardens that we have in the city, rain gardens, bioswales, different kinds of green infrastructure, it means that we can improve the quality of the water that runs through the city. And even if it overflows, the water that runs out to the lake via pump station will be a little bit cleaner because of what's happening here. Here we are at our last stop on Oretha Castle Haley Boulevard. And this is a really good spot for thinking about other approaches to managing water and how we can make a difference at each site and each building. We are above sea level now, and so again, we're closer to the river than we were previously. Drainage pump station number 1 is in that direction. So all the water that lands on Central City is flowing downhill through pipes and culverts towards drainage pump station number 1. Again, the river is behind us, behind the camera, and we're just above sea level here. So if you take a look around here on OC Haley, this is pretty typical of every street, every neighborhood in the city. What you see is a lot of asphalt and a lot of concrete, a couple of trees, and the buildings. So the buildings are no different from concrete and asphalt. When water hits a rooftop, it slides off of the rooftop and into gutters and pipes or out onto the street. So all that water makes its way quickly over to the storm drains that you see at the corners of each of these blocks. That's how water gets into the drainage systems. They're pipes that take water from each of the storm drains and again feed those into larger pipes and into culverts. And this spot, this is good for thinking about the building scale because it's exactly the size of a typical lot in New Orleans. And you can see some of the things that are possible. Of course, there's no building here, but the New Orleans Redevelopment Authority has used some of the vacant land that they own to start testing what green infrastructure and different water management strategies in the city might look like. So in this case, water that flows off the street, instead of going directly into the storm drain, is actually intercepted and flows into this lower area. So this again is a rain garden. It's dug out and it functions a bit like a bathtub with an overflow drain that's set pretty high so that this whole space, instead of going to storm drain, can fill with water. And this rain garden is filled with Louisiana irises, which are native plants that are well adapted to the edges of aquatic zones. So you might see them in natural conditions next to ponds or in wetland areas. So in this case, a rain garden is exactly like that. It periodically gets wet. And you'll also see in the back there, cypress trees, those are also native. Those also do well in periodically wet conditions. At our feet, you'll see just in this one zone alone, a couple of different ways of handling the ground and how to change some of those basic dynamics. So in this case, you see loosely compacted gravel. You see these round pavers that have gravel packed in between. And then you see these rectangular pavers that also have gaps in between. So instead of being set in mortar that hardens and becomes an impenetrable surface, all three of these surfaces allow water to, when it hits the ground, to soak into the ground. So that isn't a whole lot. It's a couple drops here, a couple drops there. But if more and more properties start to adopt some of these approaches for managing water, we can change the impermeability of most of our neighborhoods, and we can decrease the amount of water through rain gardens, through bioswales, through pervious paving like this. We can significantly reduce the amount of water flowing into the storm drains. So again, the reasons we do that are to help stabilize groundwater levels, to reduce the flow of water towards the pump station so we can spend less money and energy on pumping, and also to reduce flooding. More water held in place here means that it's less likely that pipes downstream will back up and cause street flooding either here or in other neighborhoods. As we wrap up, I think it's important to point out though that green infrastructure isn't going to solve all of our problems. When we have big rain events like we've seen already this year, multiple times last year, what we find is that the intensity of the rainfall, even though we have some of the biggest pump stations in the world, the intensity of the rainfall in our subtropical climate is so great, especially during the summer thunderstorms, that there's no size of storm drain, pipe, drainage culvert, pump station. There's no system big enough to handle if you get 4 inches of rain in an hour, or even 2 or 3. That's more than enough to overwhelm even some of the biggest pump stations in the world. And so when we think about some of the challenges we've talked about today, the sheer amount of rainfall can be so great that even our massive pumping systems can be overwhelmed. The fact that we're pumping so much, even on days like this when it's sunny, to keep the bowl from filling up with water, means that we're continually subsiding, which means different parts of the city, especially the areas that are former swampland, are continually sinking because we're constantly removing that water from that land. And at the same time, with climate change and sea level rise, our boundary conditions, what's outside, what we're pumping water out to, the lake and the Gulf of Mexico, that water level is rising. So we're fighting this very difficult battle where we're having to lift water higher and higher to get it out of the city. And so when you think about this in relation to development, green infrastructure, it's important. It's something that architects and developers and city officials, everyone's trying to figure out what's the best way to handle water in the city. And so we've looked at a couple of approaches that already exist in the city that you can come and check out. At the same time, we also have to keep our eye on climate change, on transportation policy, on complete streets programs, on all these other things that ultimately are going to shape how we think about our streetscapes, our neighborhoods, and what it means to live here in this Delta city.